I want you all to imagine what might happen to your home if the foundation began to crumble. What's worse is you might not even realize the foundation is deteriorating until one day your house begins to collapse. Our skeletons are just like the foundation of a home. As we grow old, our bones will deteriorate. Severe deterioration is referred to as osteoporosis. Both individuals you see on the screen behind me suffer from osteoporosis due to their age, poor diet, and lack of exercise. The man on the left has fallen and fractured his wrist. Severe fractures require attaching a rigid metal plate to the fracture site in order to promote healing. Problem is, if the bone is too osteoporotic, the screws might not fasten securely, rendering the plate useless. Further, increased risks associated with old age might deter an operation, despite evidence that non-operative treatment is normally not enough. The woman on the right has suffered a heart attack. She's going to need open heart surgery, meaning her chest will need to be separated into two halves in order to gain access to the heart. Once the operation is complete, the chest is put back together using wires. These wires suck. Motion between the two halves of the chest can cause severe pain, while in some cases the wires might fail altogether. An osteoporotic chest bone can exacerbate these complications. As a team of scientists, engineers, surgeons, and veterinarians, we're offering a better way to fix our bones by using an adhesive. The adhesive is low cost, easy to use, and can be injected through the skin, eliminating the need for surgery if used to treat the wrist. My job was to demonstrate the mechanical performance of the adhesive using actual human bones. We simulated wrist fractures by cutting out a wedge and injecting the gap with the adhesive while keeping its biological pair undamaged. We then compressively loaded these till failure and observed comparable failure loads between adhered and undamaged wrists. We also compared adhered wrists against their plated counterparts by applying many loading cycles, and observing that adhered wrists were way more stable than when using a plate. We compared chest bones repaired with wires alone against adhered ones by repeatedly applying normally encountered forces and measuring the displacement across the two halves of the chest. We found adhered displacement to be 500% less than when using wires alone. This suggests significantly improved stability with potential to reduce pain, shorten healing times, and avoid gruesome complications. Our goal is to get our adhesive onto the surgical market as soon as possible. Next steps include a sheep trial, immediately followed by a first clinical trial. We're focusing on the applications I presented to you all today as a starting point. However, in theory, our adhesive has countless applications, such as a bone substitute after removing a tumor. If we're successful, our treatment techniques have the potential to completely revolutionize how we fix our bones. Thank you.